Okay, third and final review problems in preparation for our test. The first one, we're given a half-life in years, and so we'll count t in years for this problem. Um, the nice thing about half-life problems is that it doesn't matter how much you start with because we're given a time amount that will give us half of however much we end up with, or we started with. So if I start with 2, then I will end up with 1 in the amount of time that it tells us. So we're going to take that 3.3 and put that in for t right here. So I'll say 1, actually divide both sides by 2 here. I get 1/2 equals e to the r times 3.3. So now I have to natural log both sides, and I have to say ln 1/2 equals 3.3 r, divide both sides by 3.3, and I get my r. So I get r equals negative 0.2100445. Okay, I'm using like a bunch of decimal places there for precision's sake. That'll be helpful for us. Our equation is now a equals p e to the negative 0.210045 t. Notice that I just replaced the r with the number I got it as, and then the t is now my input variable. T is time. So that allows me to answer the question for part B. It says assume we begin with 300 kilograms. I don't know if that's like a reasonable amount of, I don't know. And then we're taking t and putting that in there. So we'll put 2 in here. Just use your calculator. And I get 197.096 kilograms. Okay, we're starting with that same amount. We're going to keep the same equation, so it's 300 e to the negative 0.210045 t, and then we're saying equals 100 because the 100 is the cutoff value there. So we just have to solve that equation now, and so we're going to divide both sides by 300. I get 1/3 equals e to the whatever, and so that's going to give me ln of 1/3 equals negative 0.210045 t. Divide both sides by that decimal, and we get t equals 5.23 years. Okay, number 2. Number 2 says a population of ants is growing logistically and can be modeled by the function. And then we have a function where x is measured as time in days. So that's kind of an important one. Determine the carrying capacity of the ants. Well, it's just the numerator, so c is equal to 6,000. How long will it take for the population to reach 5,000 ants? So we're going to set that output equal to 5,000, and we solve the equation. The way we got to do that is multiply both sides by the denominator and divide both sides by 5,000. So that's actually just going to flip these. Variable is x equals 6,000 over 5,000. Oops, I have one too many zeros. My fault. There we go. Okay, so subtract. We have 6/5 equals 1 plus 50 e to the negative 0.08x. Subtract 1, I get 1/5 equals 50 e to the negative 0.08x. Divide both sides by 50. I get 1 over 250 equals e to the negative 0.08x. I say ln 1 over 250 equals negative 0.08x. Divide both sides by 0.08. negative, sorry. And I get x equals 69.02 days. Okay, nice. There we go. There's our first page. Second page, Lincoln is choosing to buy some more interesting investments. So let's see. We have a estimated yield of 6.8% per year. That means we're going to choose R equals 0.0678. We're going to use the same formula for any compound interest problem. It's just we're using n equals 1. So we're going to use A equals P1 plus R over N to the RNT. And so we're going to put 1 in for N. We can just kind of, if we have N being 1 right here and here, then they go away. It doesn't change the value of anything. So we'll just use A equals, oh, look at this. This is fun. You can choose how much he's going to invest. So let's choose, I don't know, 100. 1 plus 0.0678 to the T. The reason that this is kind of fun is that the doubling time is the same no matter how much you start with. So really word testing to see what happens when you have 200. But it could be any other number because you could choose a different starting amount. Okay. By the way, this decimal is just 1.0678. Not very exciting. But divide both sides by 100, we get 2 equals 1.0678 to the T. So log base 1.0678 of 2 equals T, which is 10.56, well, 10.57 years. I don't know if it's worth it. Okay, similar. We have 500 as our P. 1 plus 0.0435 over monthly means n is 12 to the 12t, like that. There's our equation. All you got to do for the next one is just take your 8 and put that in for t, and that spits out in the calculator $707.67. If it's a money question, I think you should round it to 2 decimal places. Okay, find the amount of time that it'll take for the account to be worth $650. So we put our 650 in for A, solve for T. By the way, some people are often just going to the table once they type into their y equals menu. I am not looking for you to do that. I'm not looking for an approximate answer. I'm looking for an exact answer. So just be careful of that. Divide both sides by 500. I get whatever 650 divided by 500 is, which is 1 3/10. So 1.3 equals 1 plus 0.435 over 12 to the 12t. So we got to do log base that, parentheses, of 1.3 equals 12t. Divide both sides by 12 and we get our answer, but we just need to type in our calculator to get an answer for our decimal. So, by the way, there was some point at which I lost my 0.0435. There should have been a 0.0435 and a 0.0435. That kind of threw me off when I was typing in my calculator, but I caught the mistake. Oh, wow. This gives me, I got to divide that by 12 then. So then it gives me 6 years and 349.82 as a decimal. That is 6.042 years, just over 6 years for that to reach that number. Okay, Last problem. Newton's law of cooling also works for warming or cooking or heating, and so we're going to kind of treat this problem like we would with the other ones. It's just you're going to find some kind of little interesting things that are going to happen with the R's and T's, but that's okay. All is well. Remember that we're going to use U of T equals T plus U naught minus T e to the kt. Remember that big T is our ambient temperature, and in this case, the ambient temperature is the temperature of the oven, so we're going to put 425 in here and here. We're going to put in your U naught, which is our starting temperature, which is 2 right there. And then it says after 8 minutes, we find that the pizza rolls are 125 degrees. I was going to say 125 temperatures. Okay, so we just have to rewrite, and then we're going to solve for K. So this gives me 125 equals 425 plus 2 minus 425 e to the kt. That negative is going to be what ends up flipping the function upside down so that it's warming to a horizontal asymptote instead of cooling to a horizontal asymptote. So we have to subtract the 425. I get negative 300 equals, and then this part right here I'm going to write as negative 423 e to the kt. Oh, I know what t is though, sorry. I need to have an 8 here. So that gives me, I got to divide both sides by 423. So that gives me whatever, negative 300 over, I'll just write 300 over 423 equals e to the 8k. So ln of 300 over 423 equals 8k. So k is equal to the natural log of all that stuff divided by 8. So I get, read it and weep, negative 0.429 5, I guess I'll use. I'm going to try to keep that in my calculator and use the decimal in my calculator whenever I have to do a calculation. But I'm just going to keep that as a record on my paper too. So my final answer is actually U of T equals 425, and then this time I'm going to write minus 423 e to the negative 0.0429 t. Hey, I made a mistake over here. I did that same thing where I lost the decimal place. The decimal point should have been here and not here. I'm sorry about that. I don't know why it's not letting me erase. All right, negative 0.8, oopsies, 0.4295. There we go. This is the number I want. All right, so I rewrote it over here like that. This is my function that I'm using for the problem. Okay, for the next one, it says that we are supposed to figure out how long it's going to take until it gets to 165, which is the safe temperature for food that's been cooked. So we're supposed to put in 165 for the output of the temperature. 165 equals, and then we have to solve that equation for t to figure out how long it's going to take to get there. So again, subtract the 425, divide both sides by the negative 423. So I get that equals e to the negative 0.049. I'm struggling with the decimals here today. 4295t. Just be careful. Okay, so this gives me ln of that fraction, 260 over 423, equals negative 0.04295t. Divide both sides by that decimal, and I get that t equals 11.33 minutes. which I guess is why they tell you to cook them for 12, huh? Okay. Oh shoot, we forget the pizza rolls. How hot will they be after 25 minutes in the oven? Well, this one is quick because all we have to do is we have to take our 25 and put it in for our t in our original function. So we have to do 425 minus 423 e to the negative 0.04295 times 25. And I get that they're going to be, I don't know if this is a real thing, 280 degrees. Be careful, don't burn yourself. Anyway, okay, that's all the problems from this worksheet. I hope your reviewing is going well. I will see you for your test.